Number 3 is the one that's talking about the difference between their heights. So I want to subtract the man's height and the randomly selected woman's height. And first I want to just find and interpret the average of this difference. So I'm just going to write down, if I'm finding the average of the difference, that's the same thing as substituting in m minus w. And we are allowed to subtract means. That looks like another, there we go. I could subtract the mean for the men's heights and the mean for the women's heights. So I'm just going to look at the chart and see that it's 175 and 162. Therefore, my difference would be 13 centimeters. Now, when it comes to interpreting it, remember this is after selecting many randomly selected people. So if many men and women are randomly selected, the men will be about 13 centimeters taller than the women on average. When I want the variance of this difference, so I'm going to find sigma squared of this difference. Again, this is the variance of m minus w. You do not subtract your variances. Variances still get added. So it's counterintuitive, but you always add your variances when you are combining random variables, which means I'm going to take the men's variance and the women's variance, so the standard deviations squared, and add those up, and you should get 113. So when I want the standard deviation of this difference, so if I want sigma sub d, I want the standard deviation of the difference of these. Remember, you can't just subtract standard deviations. It is still the one that looks like the Pythagorean theorem, so I want to add my variances, which I already did, square them, add the variances and then square root that result. So it's just the square root of the 113 I found before. So it's about 10.6-ish, which again means if you randomly select many men and women, the typical distance between their heights will be about 10.63 centimeters from that average of 13.